This question definitely comes off as confusing. Right away, we've got an equation that has three variables, y, x, and a, and then we have this point, the vertex, that's CD, adding two more letters into this. And so that automatically scares me. So my instinct, whenever I have a lot of letters, is to get rid of some of them because letters are hard, right? So my goal here would be to just be down to 0 letters and have all numbers. We can't quite do that. But we can still arithmetize a little bit from the start to make our lives easier. I would just start by making a equals 1 for a couple reasons. Number one, that's what I prefer, right? When I normally have quadratics, I usually don't have a number kind of outside those factors. I mean, I guess I do, but that number is 1, and so we don't write it. It's there, but it's not really effective in any way. So doing that kind of gets me back to basics. It gets me to a place where I'm more comfortable working with quadratic equations. But looking at the answer choices, I also see the a doesn't really matter. It's there, but if it's in the original equation and it's in these new equations, it's never really something that I need to solve for, so its value must not matter. And so I can make up any number, and I would just make 1, so that way when I look at these answer choices, they're easy to interpret, right? -9 times 1 is -9. -8 times 1 is -8. So really, it's just like all the a's kind of just disappeared instantaneously from this question. So that's really helpful. Now, we do need to understand the vocabulary of quadratics in order to really make sense of this question. There's a couple ways to do it, but they all kind of rely on us understanding what a vertex is, right? So just to draw things a little bit here and get some sense of what's going on, remember that a quadratic has a point, usually, we see it on the bottom, but it doesn't have to be. It could be upside down. But it's this minimum and this maximum. That's the vertex, okay? And so that's what we're trying to find. And there are lots of ways to do it, but let's stick to the algebraic way because I think that that's how most of us probably learned how to deal with this. So the way that I learned how to find the vertex is that there's a formula for the x-coordinate of the vertex that is -b over 2a. Now, what does that mean? Well, I just got rid of a, so there's something there, but mostly it has to do with the way the quadratic looks when it's in standard form. So I need my quadratic to be in, let's try to keep track of these colors, y equals ax squared plus bx plus c form. This is the same version of the equation that we use when we want to use quadratic formula. So a, b, and c correspond to the numbers that are kind of like attached to our variables. So I'm not in that form right now, but I could easily get there because I can FOIL, and so I'm going to have to do all this multiplication. So I'd start with x squared minus 2x plus 4x minus 8, and then I can combine like terms, and I'm going to write it down here, x squared plus 2x minus 8. And now things start to match up here. So my a is 1. Okay, there's no number in front of x squared, so a is 1. 2 times 1. And my b is 2, so -2. And so -2 over 2 is equal to, this is running out of space here, is equal to -1. And so that is the x-coordinate of this vertex. So the c is equal to -1. But they didn't want the c, they wanted the d, right? So we need to make sure that we find now the y-coordinate of this. And so this is actually pretty easy to do, because if we have the x-coordinate of a point, then plug the point into the equation and we'll find the y-coordinate. So we go back to the original equation, we can go to the one we have here. I'm just going to do it here because I've got the space. So -1 squared plus 2 times -1 minus 8. So that's 1 minus 2 minus 8. 1 minus 2 is -1, and then -1 minus 8 is -9. So that is the value of d. That is the y-coordinate of the vertex, and that is what choice A gives me, because -9 times the 1 that I made A is equal to -9. So it's still complicated. Even though arithmetize kind of made one of the pieces of the puzzle disappear, which helped us and helped us kind of sort through the rest of it, it's still kind of confusing. There is one other way that we can do this kind of easily, and for some of you, this may be the better way. So no judgments. Whatever makes more sense to your brain, you should do it. So let's go back to the picture I drew. Let's try to zoom in on it too so I can cut down the clutter. The vertex is a very special point, but so are these points, okay? Those are the x-intercepts. And those points we get from the factors. That's why we turn an equation that looks like this into one that looks like this. We factor to find those points. And so in this case, when y is equal to 0, x is going to be 2 and negative 4. So those are points, 2, 0, and negative 4, 0. And the vertex is always halfway between those points. Parabolas are going to be symmetrical, so whatever's going on, it's going to be the same on both sides. So if we know that the distance, it's starting to get cluttered, between this is 6, right? Negative 4 to 0 is 4. And then 0 to 2 is another 2, so that's 6. We know that the vertex has to be 3 away from each point. So 2 minus 3 would be negative 1, and negative 4 plus 3 would also be negative 1. So there we go. We have now the, again, x-coordinate of the vertex is negative 1. That's what we found algebraically before. And so then we would need to do the same exact thing that we did before, which is plug the negative 1 into the equation for x and solve. And so in this case, we would have y is equal to negative 1 minus 2 times negative 1 plus 4. That's going to be y is equal to negative 1 minus 2 is negative 3. Negative 1 plus 4 is 3. 3 times negative 3 is negative 9. And there we go. Same result that we got before. It's a mess. This is just a messy algebra test. This whole section 3 is very difficult. So, if you're not good at algebra, the no calculator section is going to be hard for you. So there are things that you can do to get better. You need to memorize a lot of stuff. The vocab around quadratics is especially important. There's really no way to make sense of this question if you don't know what a vertex is. But, these things don't change. So once they're memorized, you're good to go, right? Every time you see the word vertex, you'll kind of know some stuff that you can do around that word and hopefully solve whatever weird situation they give you. Because to be honest, this is a weird situation. So it's taking stuff that you're supposed to have learned in school that's pretty normal and standardized, and it's twisting it up, making it harder. But hopefully if we know the basics, we can kind of sort through the weird stuff and get to the answer somehow.